In the icy waters of the ocean, right in front of a human, a 10-ton creature capable of reaching speeds of up to 50 kilometers per hour and possessing colossal jaw strength surfaces. A single movement of its giant tail, and any inhabitant of the depths is defeated. However, in the entire history of observations, this absolute oceanic predator has never harmed a human in the wild. Behind this phenomenon lies the story of the most perfect creature ever to conquer the ocean, the killer whale. And it begins with a massive misconception. The famous nickname whale killer came into use thanks to sailors of past centuries who observed the collective hunting of these giants. In reality, the killer whale is the largest member of the dolphin family, although taxonomically all dolphins are also included in the toothed whale group. Before us is a species whose evolutionary path represents a stunning mystery of biology. Around 50 million years ago, the ancestor of this oceanic giant was a small land animal, Pachycetus. Over millions of years, its body fully adapted to life in the water. Yet its anatomy still preserves amazing reminders of the past. Hidden inside the killer whale's pectoral fins is a real bone structure with a hand, wrist, and fingers. And within the muscle mass, rudiments of pelvic bones remain from ancient times when their ancestors walked on land. Today, an adult animal reaches 9 meters in length and a mass of about 10 tons, which is comparable to the size of a large bus. The anatomy of the killer whale has turned it into one of the fastest and most efficient organisms on the planet. Its streamlined body allows it to reach incredible speeds, and the power of its jaws, according to researchers' calculations, is almost 5 times greater than that of the great white shark. As the renowned marine mammal researcher Eric Hoyt notes in his fundamental work, the killer whale occupies the absolute top of the food chain. In the ocean, it simply has no natural rivals. It easily outplays any inhabitants of the depths, from fast salmon to giant baleen whales. But this is precisely where the main contradiction begins. A human in open water is a slow object, devoid of natural protection. From a physical point of view, confronting a 10-ton giant is impossible. Nevertheless, when encountering a swimming human, a wild killer whale displays striking, almost conscious restraint. It does not see a human as prey, regularly demonstrating absolute indifference or reserved interest. Why does an animal that possesses crushing power and is capable of tackling any giant of the ocean strictly observe this invisible rule? The secret lies in how exactly the killer whale scans the world around it, using a perceptual system that sees far deeper than any eyes. The more people see this story, the more viewers will discover the familiar world from a completely new angle. By subscribing to the channel, you help the algorithms share this film with new viewers. Thank you for helping spread important knowledge. In the absolute darkness of the ocean abyss, where the human eye is completely powerless, the killer whale determines the shape, size, and direction of movement of an object at a distance of up to 150 meters in fractions of a second. It does not need to see its prey with its eyes. It scans the space around itself using an acoustic system superior in accuracy to any man-made sonars. The process of creating this acoustic image is mind-boggling in its physical complexity. The killer whale does not use vocal cords in the sense familiar to us. While underwater, the animal circulates an internal supply of air through its nasal passages, causing special muscular structures, phonic lips, to vibrate. The high-frequency clicks generated in this process are directed to the frontal part of the head, where a fatty organ called the melon is located. The melon works like a powerful acoustic lens, It focuses sound vibrations and sends them forward as a narrow, tightly focused beam. This impulse instantly propagates through the water. As soon as the acoustic wave collides with an object, the reflected echo returns. However, the killer whale does not catch it with traditional auditory canals, but with its lower jaw. Special fat channels inside the jawbone receive the vibrations and instantly transmit them along the auditory nerves straight to the brain. In the animal's mind, a volumetric and incredibly detailed three-dimensional map of the surrounding world is instantly formed. The precision of this system borders on science fiction. A killer whale is capable not only of detecting the presence of a fish at a distance of over 100 meters, but also of determining its specific species. The secret lies in the fact that the echolocator captures the unique acoustic resonance of the swim bladder of each inhabitant of the depths. For example, killer whales of the Pacific coast unerringly find exclusively their favorite prey, Chinook salmon, among hundreds of similar schools, easily distinguishing it from other, far more numerous species of salmon. As bioacoustician Dr. John Ford proves in his fundamental studies of cetacean acoustic behavior, the vocal repertoire of killer whales is divided into three completely distinct categories. Fast series of clicks are designed for navigation and object scanning. High-frequency whistles are used for close-range communication within the group over short distances. And powerful, pulsed calls are capable of traveling many kilometers through the water column, allowing family members to stay in touch. This is a learnable and evolving system of communication, where each type of sound conveys complex and specific information. This system allows the predators to feel confident even in extreme conditions. Killer whales are capable of diving to great depths, descending into total darkness, and holding their breath for up to 15 minutes. Their muscle tissue is saturated with a special protein, myoglobin, which binds oxygen, turning the body into an autonomous life support system. In a space where a human would require a bathyscarf and searchlights, the killer whale moves freely, reading the ocean through sound. But when this perfect natural locator is combined with incredible physical strength and passed on to a group of predators acting as a single cohesive organism, scanning turns into something far greater than a simple search. What happens when a pod of such giants decides to apply its intelligence against the most dangerous inhabitants of the planet? To disarm and neutralize the coastal water's chief inhabitant, the great white shark, in just 2 minutes without receiving a single scratch. For most creatures in the ocean, this sounds like an impossible task. But for a killer whale, it is merely a calculated physical formula. The great white shark is considered one of the largest predators in the ocean, but killer whales have found a vulnerable spot in its biology, turning the physics of the liquid environment into their main advantage. Swimming up to the shark from below or from the side, a killer whale delivers a precise strike with its powerful tail or rams it in the side, flipping the animal belly up. At that moment, so-called tonic immobility is triggered, a special reflex response of the shark's nervous system. Once inverted, the shark falls into a state of complete immobility and loses the ability to move. Next comes what scientists describe with amazement. The killer whale, with surgical precision, extracts only the giant liver, an organ extremely rich in fatty acids and squalene, leaving everything else at the bottom. Marine biologists who observed the famous pair of killer whales, nicknamed Port and Starboard, off the coast of South Africa, recorded that in 2023, a killer whale named Starboard managed to perform this entire process on a young great white shark single-handedly in less than 2 minutes. But the ability to neutralize a rival is far from the only example of their tactical mastery. In the ice-bound waters of Antarctica, killer whales demonstrate an incredible understanding of the laws of hydrodynamics. When a seal is resting in the center of a flat, floating ice floe, a solid barrier prevents a direct capture. Then a group of several killer whales lines up in a straight formation and rushes toward the ice floe at high speed, submerging into the water at the very last moment. As a result of their synchronized movement, a powerful directional wave is formed, which washes over the ice sheet, shatters it, and washes the prey straight into the water. To completely disorient the target and deprive it of the opportunity to escape, killer whales additionally release dense curtains of air bubbles from underwater. An even riskier maneuver can be seen off the coast of Patagonia in Argentina. During high tide, when the sea is calm enough, killer whales literally surf on the coastal wave, deliberately running aground on shallows and land to grab sea lion pups directly from the coastal pebbles. For a 5-ton aquatic mammal, finding itself on land is a colossal risk. On land, a killer whale loses buoyancy, can suffer severe overheating, and get stuck on the shore. To return to deep water, the animal arches its body, sways from side to side, turning parallel to the shore, and catches the next surf wave, which lifts it off the bottom. Out of the entire local population, only about 13 individuals have fully mastered this highly complex technique. Each of these methods requires ideal timing, a deep understanding of the environment, and supreme precision of movement. But no killer whale is born with ready-made knowledge of how to calculate the height of a surf wave or how to put a shark into a state of stupor. These skills are absent from their genetic program. Who acts as the mentors teaching young generations these complex techniques? And why do these traditions differ in different corners of the planet as much as human cultures do? 2 pods of killer whales can swim literally a few meters apart in the very same coastal waters, but they will never share prey, exchange sound signals, or form a common family. They are separated not merely by an oceanic barrier, but by something far more fundamental: the depth of their own cultural traditions, which over hundreds of thousands of years have effectively turned them into different species. In the waters of the Pacific Ocean, researchers distinguish 2 completely different groups of killer whales living side by side: residents and transients. Residents live in permanent, large family groups and feed exclusively on fish. They communicate continuously with one another, filling the underwater space with complex pulsed signals, clicks, and whistles. In contrast, transients are silent, roaming hunters, moving in small groups of 3 to 5 individuals. Their target is marine mammals, seals, sea lions, and other whales. Since their potential prey possesses excellent hearing, transients move in almost absolute acoustic silence, reducing echolocation to rare single clicks so as not to betray their presence. The difference between these 2 groups is so great that they prefer to keep their distance and completely ignore each other's existence. Each family group possesses its own set of unique sound signals, a true dialect. The renowned marine biologist Dr. John Ford proved in his multi-year studies that these vocal traditions are not innate. When a calf is born, its first sounds resemble loud, harsh cries, completely different from adult signals. But as it grows up, it gradually adopts the complex communication system from its mother and kin, just as a human child acquires a native language. These acoustic traditions are carefully passed down from generation to generation, smoothly evolving over the years and shaping the distinct identity of each group. Several family groups sharing similar elements of a dialect unite into an acoustic clan. When 2 pods from the same clan meet after a long separation, they arrange a breathtaking spectacle, a greeting ceremony. The killer whales line up in two straight rows opposite each other, pause for a moment, and then simultaneously rush forward, submerging into a shared, bubbling space of communication and play. This allows them to unerringly recognize relatives, maintain social bonds, and preserve the health of future generations. Biologists are convinced. Killer whales are almost the only species on the planet, besides humans, whose evolution is guided specifically by culture rather than mere physiological adaptation. Differences in diet, behavior, and language forced residents and transients to part ways, not because of climate or geography, but solely out of loyalty to the traditions of their lineage. But what internal force allows these animals to hold complex linguistic dialects, social rules, and knowledge passed down through generations in their memory? The answer to this puzzle lies in the structure of an organ that, in some respects, is far more developed in them than in humans themselves. If you weigh the brain of a killer whale, the scale pointer will stop at nearly 7 kilograms. But the real shock lies not in its absolute weight, but in the patterns on its surface. Before us is the most gyrified and architecturally complex brain among all creatures that have ever existed on our planet. The brain of this ocean giant weighs from 5.5 to 6.8 kilograms, roughly 5 times heavier than a human brain, second in mass only to the sperm whale. However, size alone does not guarantee an advanced intellect. In neurobiology, the encephalization quotient, the ratio of brain mass to body mass, as well as the surface area of the cortex, is important. Due to the enormous weight of the killer whale itself, its quotient is formally lower than a human's, but the absolute volume of the cortex and a huge surplus of neural tissue not occupied by simple body control are dedicated to higher cognitive functions. The main difference lies in gyrification, the degree of folding and convolution of the hemispheres. The more folds packed into the cranium, the more neural connections work simultaneously. The gyrification index in humans is 2.2. In the bottlenose dolphin, it is 5.6. And in the killer whale, it reaches a record high of 5.7. This is an absolute record for cortical gyrification on Earth, allowing instant analysis of complex streams of information, from echolocation to social interactions. The renowned neuroscientist Dr. Lori Marino, in the study Brain Evolution and Cognition in Cetaceans, demonstrated that the killer whale brain possesses a unique anatomical structure. Changes affected the areas responsible for processing complex feelings. Killer whales have an incredibly developed insular cortex and paralimbic system, regions of the brain that shape emotional intelligence, self-awareness, compassion, empathy, and the perception of the state of other group members. In these marine inhabitants, the neural networks of emotional perception extend far beyond standard structures, forming connections that simply do not exist in humans. The ability of killer whales to be self-aware was proven in a series of scientific experiments using the mirror test. When researchers applied marks with harmless dye to the animals' bodies in places visible only in reflection, the killer whales changed their behavior. They purposefully swam to the mirror, turned at the right angle, examined the painted areas specifically, blew air bubbles, and closely studied their reflection. This is scientific proof. The animal clearly distinguishes between the concept of self and the surrounding world. We are looking not just at a marine inhabitant, but a personality endowed with a complex inner world, capable of feeling deeply, analyzing past experiences, and building unbreakable bonds within its kin. But how does this giant emotional intellect, programmed for empathy and affection, behave in moments of severe trial and the loss of loved ones? The answer to this question is hidden in a story that the whole world followed. The ocean is a harsh and pragmatic place, where every living creature is subject to a single goal: to leave offspring and yield place to new generations. But in these cold waters live giants who survive for decades after completely losing the ability to reproduce, devoting the rest of their days to preserving the memory of their lineage. Almost all animals on Earth reproduce until the very end of their life path, as evolution tolerates no wasted energy. However, killer whales belong to a tiny, exclusive club of species, along with humans and a few other cetaceans, whose females go through actual menopause. At around 40 years of age, they stop bearing offspring, but continue to live. 30, 40, and sometimes even 50 additional years. Researchers recorded a matriarch nicknamed J2, who, according to biologists' estimates, confidently passed the 90-year mark. More than a third of an adult female's life is spent in the status of an elder. Why does the ocean preserve the life of a creature that no longer increases population numbers? She stops being merely a mother and becomes a grandmother, a living encyclopedia of survival. In large-scale multi-year observations conducted by biologists from the University of Exeter, a striking fact emerged. Calves whose grandmothers are alive have dramatically higher chances of survival. This effect is most pronounced in years of severe food shortages, when salmon numbers drop to critical levels. At such moments, it is the oldest females that step to the forefront of the pod and take charge. They lead their family to hidden hunting grounds, navigating by a memory map stored in their brains long before the other group members were born. The elder remembers past droughts, migrations, and prey habits, saving the young from inevitable starvation, and sometimes giving them up to 90% of the fish she catches herself. The loss of such a female for a family is not just the loss of a relative. It is a fire in the only library of priceless knowledge. And it is precisely this deep, emotional intelligence, tied to family bonds, that gives rise to heart-stopping moments. Killer whales do not simply protect their pod. They are capable of experiencing loss with an intensity frighteningly similar to human grief. In the summer of 2018, a female of the southern resident population named Tahlequah gave birth to a calf that stayed with her for only about half an hour. By the laws of pragmatic nature, she should have left it behind and moved on for her own survival. But Tahlequah refused to let her child sink to the bottom. For 17 days, she continuously swam through ocean waters, holding her lost baby on her head. She covered more than 1,600 kilometers, losing strength, while other members of her family occasionally supported the baby, giving her a chance to catch her breath. In this exhausting journey, there was no biological benefit, no gain for the survival of the species. It was simply a mother who could not bring herself to say goodbye to her child. We see before us creatures endowed with incredible empathy, capable of profound affection and the careful transmission of knowledge through centuries. But if this mind is so noble, logical, and dramatic, how can one explain the sudden, completely absurd, and inexplicable fads that sometimes sweep through these pods, causing them to behave entirely irrationally? In the summer of 1987, off the coast of the Pacific Northwest, a killer whale surfaced with a salmon on its head, as if wearing a quirky hat. A couple of weeks later, several family groups in the region picked up this trend. This case went down in scientific history as one of the strangest examples of cultural fads among wild animals. The behavior persisted for one summer and then completely disappeared for nearly 40 years. Biologists long considered it a one-time anomaly, until, in the autumn of 2024, a male named Blackberry surfaced with the exact same salmon hat on his snout. Fashion returned 4 decades later. These animals are capable of performing actions that have nothing to do with survival, food acquisition, or reproduction. They do it simply because it is interesting, unusual, or popular among their peers. But when such mass fascinations clash with the human world, the results begin to look intriguing and even alarming. Starting in 2020, off the coasts of Spain and Portugal, in the area of the Strait of Gibraltar, a group of killer whales began demonstrating completely new behavior. They started regularly swimming up to sailing yachts, pushing rudders, and periodically breaking them with astonishing precision. One of the first to display these actions was a female named White Gladys, by scientists, named in honor of the old scientific name of the species, Orcas gladiator. The behavior was picked up by other individuals in the group, and over several years, researchers recorded around 700 such encounters. In some cases, the damage to the rudders proved so severe that the vessels required assistance, and a few sailboats ultimately lost buoyancy altogether. Sensational headlines about a conscious confrontation between the ocean and humanity immediately erupted in the press. However, the real scientific picture turned out to be far more interesting. In 2024, an international working group published a special report shedding light on this phenomenon. Experts concluded that this behavior is not a manifestation of negative intent. We are looking at a classic oceanic game or another enthusiastic trend. For a curious and highly intelligent animal, a sailboat's underwater spinning rudder is simply an engaging, dynamic toy. A few well-fed seasons with an abundant fish supply freed up time for the killer whales, which they decided to spend exploring strange objects floating through their territory. But in this story, there is a detail that shocks researchers most of all. When a damaged yacht begins taking on water and people are forced to abandon ship, finding themselves right in the open sea, the killer whales instantly lose all interest in what is happening. They simply freeze, watch, or calmly swim away. They disable the mechanism, but completely leave the human untouched, just a few meters away. Why does the killer whale completely refuse the easiest prey on the planet? The first explanation lies in their strict cultural traditions. A killer whale's diet is not an instinct to grab everything that moves, but a clear system of knowledge passed down from older females from generation to generation. For instance, Pacific Coast residents will suffer severe hunger during a salmon population crash, yet will not even touch seals swimming right next to them. An object not listed on the menu by the elders simply does not exist for them as food, and humans are not in this food system. The second reason is how we appear on the screen of their internal echolocator. Unlike a fish with its unique swim bladder or a seal with its dense layer of blubber, a human sounds completely alien to a killer whale. Air-filled lungs, a different bone density, a synthetic wetsuit, and strange movements on the surface make us, in the eyes of the predator, a hollow and thoroughly unappetizing object. From a biological standpoint, a human is an extremely disadvantageous deal for a 6-ton giant. Killer whales critically need high-calorie fat to maintain body temperature in cold water. Even those individuals that hunt great white sharks delicately extract only the nutritious liver, ignoring dense cartilage and muscle. Humans in wetsuits would require more energy to digest than they can provide. Yet even when an accidental mistake occurs in murky water, the level of self-control in these animals is astounding. In 1972, off the coast of California, surfer Hans Kretschmer was paddling in opaque water. A wild killer whale surfaced and grabbed his leg, confusing his silhouette with a seal's. But in that very same second, Feeling neoprene and thick fabric, it instantly released its jaws and swam away. The mistake was corrected in fractions of a second. The predator immediately realized that it was not dealing with prey. There is another interesting hypothesis. In the past, humanity actively engaged in whaling, inflicting severe damage on family groups. And since the oldest females live for around 100 years, there are still individuals in the ocean who remember those times. Perhaps the experience of interacting with humans formed an important tradition, to keep a distance and avoid direct conflicts. We are used to looking for intelligence among distant stars, failing to notice that an extraordinary underwater world lives right beside us. With its own dialects, the transmission of knowledge from grandmothers to grandchildren, trends, and deep support among kin. And most striking of all, this oceanic giant, possessing incredible strength, shows astonishing restraint and wisdom toward human beings.